Hi everyone. Notes 4.1 are on integer exponents. So we're going to do a quick review of what we learned in the 1D class, and then we're going to take it a little bit further to some new material for our 3U class. So the first thing it asks us to do is to consider the expression 5 to the power of 3. Now in expanded form, 5 to the power of 3 just simply means 5 times 5 times 5. Okay, so when I'm expanding it, I'm just writing out all the 5s that this exponent is telling us to do right here. Exponential form is just our answer, our expression here with an exponent. So we need a base and an exponent. So it's 5 to the power of 3, where 5 right here is our base and 3 is our exponent. Okay. All right, awesome. So now we want to talk about the power of a negative base. So we want to find the difference between negative 3 to the power of 2 and then negative 3 without brackets to the power of 2. So right here, because we have brackets, it's saying that everything inside of my brackets is being raised to the power of 2. So what this means is negative 3 multiplied by negative 3, and a negative times a negative is a positive, so I should get positive 9 here. Okay? But the next expression that we have here is negative 3 to the power of 2. So the only thing that's being raised to the power of 2 is 3. So what this means is 3 times 3, and then this negative here just kind of goes along for the ride, so it's a negative 3 times 3. So 3 times 3 is 9. With a negative tacked on, we get negative 9. So the difference that we have here is that in negative 3 to the power of 2, negative 3 is the base. Okay? In negative 3 without brackets to the power of 2, 3 without the negative is the base. Okay? Now, sometimes you're going to get different answers, and other times you're going to get the same answer. So, for example, if we had negative 4 to the power of 3 right here, that means that my base is negative 4 because it's in brackets. So that means negative 4 times negative 4 times negative 4. Well, a negative times a negative is a positive, and then a positive times a negative is a negative. So the 3 negatives here turn into a negative, and then 4 times 4 times 4 is going to be 64. So my answer here is negative 64. Now, if I have negative 4 to the power of 3, what that means is my base here is just 4, so it's 4 times 4 times 4 with a negative kind of going along for the ride. So 4 times 4 is 16. 16 times 4 is 64 with a negative in front. My answer is negative 64. So it happens to be the same answer. So sometimes you'll get the same answer and other times you won't. So you have to be really careful about understanding what your actual base is going to be. Okay? Okay, so right here it says if the base of an expression in exponential form is either negative or a fraction, you must have brackets around the base always. That's really important that you make sure you do that, okay? So for example, if my base is 1/2 and my exponent is 3, I have to say 1/2 in brackets to the power of 3 to indicate that I'm multiplying 1/2 by itself 3 times. Without the brackets, the only thing that's being raised to the power of 3 is the 1. So what this means is 1 times 1 times 1 all over 2, which is just 1/2. That is not the same thing as saying 1/2 times 1/2 times 1/2. Okay? So let's do a review of our exponent laws from grade 9 math. So when we are multiplying powers, when multiplying powers with the same base, you need to add the exponents. So for example, if I had 5 to the power of 2 times 5 to the power of 4, essentially what that means right here is 5 times 5, that's what 5 to the power of 2 means, and then another 4 5s being multiplied together. So therefore, I can just simplify that and say that this ends up being 5 to the power of 6. So the shortcut is just to add the 2 and the 4 together, so I end up getting 5 to the power of 6. Okay, if I had x to the power of 200 times x to the power of 103, then when I multiply, I need to add my exponents. So I end up getting x to the power of 200 plus 103, or simply x to the power of 303. Now, obviously, you don't have to write this piece out every single time. I'm just writing it out for you so you can see where these numbers are coming from. Okay, so now the next one is the quotient law. And remember, the word quotient means to divide. So when dividing powers with the same base, this time we're going to have to do something different. So let's figure out what we have to do. So for example, if I had 8 to the power of 5 divided by 8 to the power of 2, what that means is 8 times 8 times 8 times 8 times 8 all over 8 times 8. Well, a bunch of my 8s are going to cancel out. So this 8 goes with this 8. This 8 goes with this 8. So I end up getting 8 to the power of 3. So when I have a 5 in the numerator here and a 2 in the denominator here, I ended up getting 8 to the power of 3. So the shortcut is I can just subtract the exponents. Okay, so again, if I have x to the power of 200 divided by x to the power of 103, I end up getting x to the power of 200 minus 103, which is x to the power of 97. So my answer here, same thing, I don't have to show this workout right here, but just showing that I have to subtract my exponents whenever I'm dividing, okay? Okay, the power law. When you have a power that is raised to a power, what are you going to have to do? So if I have 7 to the power of 2 raised to the power of 3, what that means is I'm going to have 7 to the power of 2 3 times. So it's 7 to the power of 2 times 7 to the power of 2 times 7 to the power of 2. But we know that when we multiply, we add our exponents, so we get 7 to the power of 6, right? But the shortcut with the 2 and the 3 is we can just simply multiply the exponents. Okay, so for example, if I had x to the power of 500 and that was raised to the power of 3, that means that I would get x to the power of 500 times 3, which is x to the power of 1500. Now, do not get that confused with x to the power of 500 times x to the power of 3. This is still going to be x to the power of 503. So here we have a power raised to a power. Here we're just multiplying two different powers. Okay, last review part until we get to the new stuff. So if we if we have power of a product or quotient, what we need to do is apply the exponent to each base in the product or quotient. So for example, if I had a times b to the power of m, this right here is my product right here, and it's the power of a product. So what this means is I'm allowed to just say a to the power of m times b to the power of m, okay? So I'm allowed to distribute pretty much that exponent to everybody inside of here as long as it is, as long as it is multiplication here. Remember, if it's addition or subtraction, you're not allowed to do that, okay? And then same thing is true for a quotient. So if I were to divide a by b and did that to the power of m, I'm allowed to say that it's a to the power of m over b to the power of m. Okay, that's allowed. So for example, if I had 2/3 squared, what that really means is 2/3 times 2/3, which is 2 times 2 is 4, 3 times 3 is 9. So my answer would be 4/9. But I'm allowed to also just say that 2/3 squared is just 2/3, is just 2 squared over 3 squared, so I end up getting 4/9 again. So either way, it is correct, but I just want you to understand that you can actually tag that exponent along to each part of your quotient, okay? Right, so this is where things are going to start to get a little bit newer, okay? So let's evaluate some of the numbers that we have inside of our chart right here. So 3 to the power of 3 just means 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27. So 3 to the power of 3 is 27, okay? 3 to the power of 2 just means 3 times 3, which is 9. 3 to the power of 1 just means 3. Okay, now if you guys notice, the exponents are all decreasing by 1 right here. So what's happening right here? Well, every time I have 1 less 3, I'm essentially just dividing by 3 every single time. So right here, to go from 3 to the power of 1 to 3 to the power of 0, if I'm going to go down by 1 less 3, I have to divide out one of those 3's. And 3 divided by 3 is going to be 1. And a common mistake that people will make is they will think that this right here is going to be 0 because you see a 0 power. But you need to be really careful because, for example, you don't have to write this down, but just watch this. If I have 5 to the power of 6 over 5 to the power of 6, what this means is 5 to the power of 6 minus 6, or 5 to the power of 0. And anything divided by itself is always going to be equal to 1. So anything for that is raised to the power of 0 will always give me 1 as my answer, no matter what. It's always going to be 1. One last thing to think about is that everything here cancels out right here. But when things cancel out with division, they always cancel out to give you the number 1. The only time that things cancel out to give you 0 is when you're adding or subtracting, but with division, you always end up getting the identity of 1, okay? All right, so let's keep going. This 3 to the power of 0 went down to 3 to the power of negative 1. So we're also going down by 1. We're still continuing that trend with my exponents. So same thing here, I'm going to want to divide by 3. Now, I'm not actually going to type that into my calculator. I'm literally going to write 1 divided by 3, or 1/3. Okay, then to get to my next one, I'm going to divide by 3 again. So what this means, what's going to happen, and I do want you to write this down for me, please. It means I'm going to take 1/3 divided by 3. But remember, when you're dividing with fractions, we can change this to multiplication and then do the reciprocal. So this 3 over 1 becomes 1 over 3. So I end up getting 1 over 9. So this right here would end up being 1 over 9. Okay, and I wrote this to the left on purpose because I need some room for a couple more things to write down here. Okay, then I'm going to do the exact same thing again. This went down by 1, so it's 1 less 3. So this time I'm going to take 1/9, and I'm going to divide that by 3. Well, what that means is 1/9 times 1/3, because I have to do the reciprocal, so I end up getting 1 over 27. So this right here is 1 over 27. Now, one thing I want you to notice is that right here, when we have 3 to the power of 2, we got 9. When we had 3 to the power of negative 2, we got 1/9. So that means that this is essentially 1 over 3 to the power of 2. Okay? And then when we had 3 to the power of negative 3, we had 1 over 27. When we had 3 to the power of 3, we just had 27. So this essentially is just 1 over 3 to the power of 3. So what does this all mean? It ends up giving us two really important laws. The first one is the zero exponent law that says that anything to the power of 0 is always going to equal the number 1. So it always equals 1. So for example, if I had negative 81 over 27 x plus 54, but the whole thing is being raised to the power of 0, I still get 1. If I get 32 raised to the power of 0, I get 1. But just be really careful, because if I had something like 7 times 4x to the power of 0, a lot of people will still tell me that this is 1. But according to BEDMAS, I have to evaluate my exponent first. So this ends up being 7 times 1, which is 7. So please make sure that you get those two things clarified in your head, when you should actually multiply by the 7 and when it should actually be to the power of 0. One other thing to notice also is that the 7 is not being raised to the power of 0, so I can't say that it's 1. Okay? All right, for negative exponents, what you're going to do is, because we're dividing every single time, and when we divide, we multiply by the reciprocal, we're just going to take the reciprocal of the base. So pretty much when we take the reciprocal, we're going to flip the base, okay? And then we're going to change the sign of the exponent. So if you notice right here, our base was 3. We did the reciprocal of 3, so we did 1 over 3, and then we made the exponent a positive 2 instead of a negative 2, okay? Now the way I wrote it out here is mathematically correct, but I'm going to actually have you guys write it out slightly differently in our examples over here. So example right here, if I had 5 to the power of negative 2, what this means is I have to take this 5, do the reciprocal of it, so I get 1/5 raised to the power of 2. So that means that I get 1 squared over 5 squared, or just 1 over 25. Okay? Another example that you could see is if you had, for example, 3 over, let's say 3 over 2 to the power of negative 3. So that means that I have to do the reciprocal of my base. It's technically 1 over 3 over 2, but remember 1 over 3 over 2 just means 1 divided by 3 over 2, which means 1 times the reciprocal, which is 2/3. So we can just say that we just do the reciprocal here simply and get 2/3. So we end up getting 2/3, and then this negative 3, we change the sign of it, becomes a positive 3 because I've done the reciprocal. And then it ends up being 2 to the power of 3 over 3 to the power of 3. Well, 2 to the power of 3 means 2 times 2 times 2, which is 8. 3 to the power of 3 means 3 times 3 times 3, which is 27. So my answer here would be 8 over 27. Okay. All right, so let's do this. 5 to the power, first of all, the directions say write in exponential form with non-negative exponents, and then evaluate. So our first example that we have here is 5 to the power of negative 3. We have a negative exponent, so we need to rewrite this. Well, this is technically 5 over 1. So what this means is I'm going to do the reciprocal of it, and it's 1 over 5 to the power of 3. Another way to write this is also 1 over 5 to the power of 3, because 1 to the power of 3 is just 1, okay? So here are my answers for my non-negative exponents. So now to actually evaluate, I'm going to do 1 over 5 times 1 over 5 times 1 over 5. And 1 times 1 times 1 is 1. 5 times 5 is 25. 25 times 5 is 125. So my answer is 1 over 125. Okay, so the next example here in exponential form just basically means negative 1 over 4, because we do the reciprocal to the power of 2. So then if I want to evaluate it, what it means is negative 1/4 times negative 1/4. So a negative times a negative is a positive, so I get positive 1 over 4 times 4 is 16. So this is my answer when I evaluate it. Okay, the next one, be really careful. Here, my base is simply just the number 3. So what this means is that the negative is going to go on the outside. Then I take my base of 3, do the reciprocal of that value, and then make this to the power of 4. So this is my answer in exponential form. And then if I want to figure out what it actually is, what it means is I've got a negative on the outside, and then remember we can just say 1 to the power of 4 over 3 to the power of 4. The negative just tags along. 1 to the power of 4 is going to be 1, and then 3 to the power of 4 means 3 times 3 times 3 times 3. This is 9, this is 9. 9 times 9 is 81. So my answer is negative 1 over 81. Okay? For the next one, we've got 12 to the power of 0. So this is already in exponential form with non-negative exponents because my exponent is 0, which is non-negative. Then to evaluate, I end up getting anything to the power of 0 is always 1. So my answer here is 1. Okay? All right, for the next one, this is also in exponential form because I have a non-zero exponent here. Or sorry, a non-negative exponent. So here, this time my base is negative 12. So because my negative is inside of my brackets, then all of this number is being raised to the power of 0, so I end up getting still 1. Okay? Now, for this next one right here, again, it's in exponential form with non-negative exponents. So that part is good, but now I need to evaluate it. And this time, my base is just 12. So essentially what this is saying is I'm going to take 12, raise that to the power of 0 with a negative in front of it. Well, 12 to the power of 0 is 1, and then this negative just tags along, so it's negative 1. For the remaining 9 examples, if you are going to Europe or you are on the Europe trip, or you've come back from Europe, I would like for you to please continue watching this video. If you are not on the Europe trip, I would like you to go ahead and stop watching, and we'll talk about the remaining 9 examples next time I see you guys in class. This one is also in exponential form with non-negative exponents. So here I end up getting 16 to the power of 0 is 1, and the negative just tags along right here, because again, my base here is still just 16. Okay? Next one, 1 over 4 to the power of 2 is already written in exponential form with non-negative exponents, so I don't need to do any flipping at all. So here it just means 1 squared over 4 squared, which is 1 over 16. Okay? The next one, however, needs to be rewritten because it says that we need to have non-negative exponents, and my exponent here is positive. So because it's negative, sorry, my exponent here is negative, excuse me. So because it's negative, I'm going to take 1 over 4, flip it so that it becomes 4 over 1, and then make my exponent positive. Well, 4 over 1 is just 4, so it's just 4 squared, which is 16. So this is my answer to rewrite it with a non-negative exponent, and that's how you get the evaluated answer. Okay? Next one, 4 to the power of negative 4. What this means is I have to take the reciprocal of the 4. So I get 1 over 4 to the power of positive 4 since I did the reciprocal. So 1 to the power of 4 over 4 to the power of 4. 1 to the power of 4 is 1. 4 to the power of 4 means 4 times 4 times 4 times 4. 4 times 4 is 16. 4 times 4 is another 16. 16 times 16 is 256. So this is my evaluated answer, and this is my answer right here with a non-negative exponent. All right, next one right here is negative 3 to the power of negative 3. So here my base is negative 3. So what this means is I'm going to take negative 3, do the reciprocal of negative 3, so I get negative 1/3, and raise that to the power of positive 3. So this is my answer here with a non-negative exponent. So then what I need to do next is figure out what my answer is going to be. So what this means is it's negative 1/3 times negative 1/3 times negative 1/3. So negative 1 times negative 1 times negative 1 is negative 1. And 3 times 3 is 9 times 3 is 27. So my answer is negative 1 over 27. All right, the next one is a little bit trickier. So for the next one, what it's saying is 1 over 2 to the negative 1 power means I have to do the reciprocal of 2. So I get 1 over 1/2 raised to the power of 1. But we don't want fractions within fractions. So what this means right here is just simply 1 divided by 1/2 to the power of 1. Well, 1 divided by 1/2 to the power of 1 is just 1 divided by 1/2. But when we have division with a fraction, it just becomes 1 times the reciprocal of 1/2, which is 2. So my answer here is just simply 2. Okay, so if we have a negative exponent in the denominator, we can still flip it. So essentially what this is saying is that this negative is not allowed to be in the denominator. It now needs to be in the numerator. So essentially what it's saying is just 1 times 2 to the power of 1. Here's this 1. And then this 2 flips to the numerator, becomes 2 to the power of positive 1. Okay? All right, awesome. So now 2 more questions and then we'll be good to go. So the next one right here, we have negative 2 raised to the power of 5. It already has a non-negative exponent. So this is the answer in exponential form with a non-negative exponent. So essentially what this means is just negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, I know that negative 2 times negative 2 is positive 4. And then another negative 2 times negative 2 is also positive 4 times negative 2. So 4 times 4 is 16 times negative 2 gives me negative 32. Okay, now I purposely gave you this example here because a lot of people will tell me that this answer is negative 32 when it's not. The only way that you'll get negative 32 as your answer is if the negative is part of the base and not part of the exponent. So remember what this means is 1 over 2 to the power of 5. So then I just get 1 to the power of 5 over 2 to the power of 5. 1 to the power of 5 is 1. 2 to the power of 5 means 2 times itself 5 times, which we figured out is 32, but just a positive because this 2 is positive. The base is positive, so my answer should be positive. Okay, last one. We're going to evaluate this a couple different ways. So the first method that we could figure this out is just to work from the inside out. So 5 to the power of 12 times 5 to the power of negative 7, I have multiplication, so I'm going to add my exponents here. So I end up getting 5 to the power of 5 over 5 to the power of 8, all raised to the power of negative 2. So then I end up getting I'm going to evaluate what's inside of my brackets here. So if I have 5 to the power of 5 over 5 to the power of 8, I'm going to subtract those exponents, so I get 5 to the power of negative 3 raised to the power of negative 2. Well, if I have a power raised to a power, I can just multiply them, so my answer is going to be 5 to the power of 6. And then when I evaluate it, I need to figure out what 5 times 5 times 5 times 5 6 times is going to be. So 5 times 5 is 25. So essentially, I've got 3 25s being multiplied together. And then 25 times 25 is 625. Okay, so then when you multiply 625 by 25, you end up getting 15,625. So that's your answer when you evaluate it. Okay?